Hi and Assalamualaikum. My name is Muhammad Imran bin Zadi, and today I will be presenting my final year project titled Generative Enhancement of Low Quality Chest X-ray Images Using Generative Adversarial Networks, with my supervisor being Dr. Muhammad Razif bin Samsudin. For the background of study, chest X-ray or CSR is one of the most widely used imaging modalities for screening thoracic diseases such as pneumonia, tuberculosis, and lung cancer due to its efficiency and relatively low radiation dose. Chest X-ray imaging requires careful radiation dose management and is sometimes performed using portable or bedside systems, both of which can influence image characteristics such as noise, contrast, and spatial resolution. With recent events in artificial intelligence, generative adversarial networks, or GANs, have gained attention for their ability to enhance medical images by improving visual quality while preserving important diagnostic information. Now, for the problem statement, despite the widespread use, chest X-ray imaging faces two main challenges. First, under ALARA guideline, which is as low as reasonably achievable, reducing radiation dose often increases image noise and reduces image detail, while dual exposure techniques such as dual energy subtraction increase radiation dose and are prone to motion artifacts. Second, portable and bedside chest X-ray imaging commonly suffer from blur, noise, and resolution degradation, which reduces diagnostic quality and negatively affects computer-aided image analysis systems. Now, based on these challenges, this study aims to answer three research questions. First, what gun-based approaches are suitable for enhancing low-quality chest X-ray images? Second, how can a gun-based enhancement model be developed using the NIH chest X-ray datasets? And third, how effective is the proposed model in improving image quality? And the corresponding objectives are to identify suitable gun methods, develop a gun-based enhancement model, and evaluate its effectiveness. Now, the scope of this study focuses on gun-based deep learning techniques for chest X-ray image enhancement. The NIH chest X-ray dataset obtained from Kaggle will be used for training and evaluation, and pair low quality and high quality images will be generated to support supervised gun training, and model performance will be evaluated using objective image quality metrics such as PSNR and SSIM, as well as qualitative visual assessment. This research aims to 1. Improve visual quality of chest X-ray images, 2. To support more accurate clinical interpretation and computer-aided analysis, and 3. Is to offer a cost-effective and scalable solution without changing imaging hardware. Now, let's move on to literature review. The memo that is saying right now is summarizing the literature review conducted for this project, and the review is structured around six key components. First is the domain, which focuses on medical imaging. Second is the dataset, where the NIH chest X-ray dataset is used, and also the pair data is synthetically generated. And third, the challenges, which include low dose imaging and the noise or blurry chest X-ray images. And the fourth one is key finding and gaps, where key finding is gun enhanced images and gaps in weak semantic preservation analysis. And for the fifth one is the related work, which highlights the gun-based approaches such as ESR gun and real ESR gun for image enhancement. And finally, the evaluation metrics, where PSNR and SSIM are widely used to assess the enhancement performance. Now, for the system architecture, the process begins with preliminary study, where a literature review is conducted to understand the existing gun-based image enhancement methods and to clearly define the research problem and scopes. Next, the training data is prepared and the gun model is designed and trained using the prepared dataset. And finally, a working prototype system is developed and a evaluation process is carried out to assess the model performance using the quantitative metrics and visual comparison. Now, moving on to research methodology. The methodology consists of three main phases. The first one is the preliminary study and analysis. This phase focuses on the literature review of the project and where the data is collected. The second phase is model design and development. This is where the data is pre-processed, the system architecture is designed, and the model is developed. The third and the final phase is implementation and evaluation. In this phase, the prototype will be working and will be evaluated using the metrics that are set. Now, for the expected outcome for this research is a functional gun-based prototype capable of producing chest X-ray images with reduced noise and improved structural clarity while preserving the important anatomical details. Also, for the performance evaluation, the expected is to improve PSNR and SSAM values compared to low-quality input images and visual comparison showing clearer structure and improved image quality. Now, this Gantt shows the project timeline from the October 2025 to July 2026 and outlining each phase from knowledge acquisition through model development and evaluation. And with that, I conclude my presentation. That's all for me. Thank you.